All right, good morning, everyone. We're going to be moving on to seventh grade lessons now, a little bit of a challenging step for our sixth grade students. So let's move on to lesson 1-1, which is a lesson we partially covered in sixth grade, dealing with absolute value a little bit. So it is lesson 1-1, relating integers and their opposites. So let's look at example 1. Alexis is shopping on the ground floor of the mall when she realizes she left her phone in the car. She walks down 6 floors to the underground parking garage. How far will Alexis walk to get back to the ground floor? Use integers to explain. So first of all, worst feeling when you leave something in the car, especially a phone. Not a great feeling. So some places, especially at malls and maybe theaters or other places, they sometimes build an underground parking lot as to not take up space for the actual mall or the structures itself. So they'll build into the ground. So this girl Alexis does not mean she parked on floor -6. This just means it's 6 levels down from the main floor, and the main floor is going to be considered integer 0 because that's at the ground floor. So our friend Alexis over here, she was at the ground floor, and now she has to go back down to the 6th floor beneath to get her phone. So she's going down 6 floors. So if you're going down, that could also be represented by -6. So -6 represents Alexis's position after she walks to the car. But then Alexis is going to return back to the ground floor. So she's going from 6 floors down all the way back up to floor 0, which is the ground floor. So she's going to go all the way back up to 0. So, which is illustrated right here, she went down 6, which is -6, and then she went up 6. So if we look at our statement over here, -6 and 6 are considered opposites. Opposite quantities combine to make 0. So remember, the word combine, we're thinking about adding. So -6 plus 6, that is equal to 0. They're both equidistant, or the same distance from 0. -10 plus 10, that's also 0. So any two opposites, they have the same distance from 0, and when you add them together, it equals 0. Okay, moving on to question 2. Samuel has $20 in his savings account before he makes a deposit of $160. After 2 weeks, he withdraws $160. How did Samuel's savings account balance change? So here they show us that his initial balance is $20. Pretty good if you have $20 in your bank account, right? So he's at $20 right there. Deposit is a word that we love. That means we made money. So, or we're putting money into our account, like maybe birthday gifts, or you worked, or you got tipped somewhere for doing work. So he's getting $160 added to his bank account. So his bank account's going way up, and we're going to add 160. I'm going to write plus 160. And now it's going to land us at $180 because 20 plus 160 is 180. So deposit is a good word for us. Deposit means make money or enter money into your account, make money. And withdrawal is the opposite of that word. So withdrawal means take out money. Withdrawal means take out money, or you have to pay your bills or something when you get older, or you want to buy something, so you have to take that money out, take out money. So it's the exact opposite. So now he's going to take away, withdraw 160, so he's going backwards. So I'm going to write minus 160. So first he put 160 into his account, then he took away 160 from his account, and now the answer is there was a $0 change. So he didn't make money or lose money after this was all said and done. Okay, so there was a change of $0. So he's back, by the way, to his original $20. He didn't make or lose from that 20. He's back to $20. So there was a $0 change. He added 160 into his account, and he took away 160. Okay, example 3. One winter morning, the temperature was freezing outside. This reminds me of college. I was in college in Oneonta, which is in upstate New York near Albany. It was cold. It used to snow. I've seen snow on May 1st before, so it was cold sometimes. So it says it was -2 degrees Celsius out. Then by 11 a.m., the temperature has decreased, or had decreased, by another 3 degrees. At 4 p.m., the temperature reached 0 degrees. All of these are very cold temperatures, by the way. So what integer represents the temperature change from 11 to 4? Okay, so first, I'm going to make my own style thermometer, I guess we'll call it. So let's see. We're going to say that we'll put 0 up here, -1, -2, -3, -4, -5. Okay, so let's show our movement on our thermometer. So at 11 a.m., the temperature was -2. So I'm going to put a nice blue dot right there, and I'll put a blue dot. We'll make like a little key over here. This was at 11 a.m., the blue dot. Then the temperature decreased by 3 degrees. So let's see. That means decreased, it went down. It got colder out. So it went down 1, 2, 3 degrees. So my new part, the temperature went down by 3 degrees. Let's pick a color. We'll pick here. So sorry, it was at it was -2 degrees. Then by 11 a.m. it went down 3 degrees. So I'm sorry. Let's fix this a little. This is going to be 11 a.m. Sorry about that. 11 a.m. is pink. The morning time one is going to be the blue one. This is some point early in the morning. We'll fix that. Morning. And then it says at 4 p.m. the temperature reached 0 degrees Celsius. So that means, let's try to draw it nicer. So it went up by 1, 2, 3, 4, 5. So it ended back at 0. So that means from 11 a.m. till 4 p.m. we had a 5-degree increase. The weather went all the way from -5 to 0. So there was a 5-degree increase, because to go from -5 up to 0, we can count up -4, then -3, then -2, then -1, and then 0. So the weather from 11 a.m. when it was at -5 degrees until 4 p.m. when it was at 0 degrees, there was a 5-degree change.